You know that feeling when you're on a plane, you look out the window, and you kind of just wonder, what's really keeping this whole thing safely in the sky? Well, I can tell you it's not magic. It's engineering. And today, we're going to break down one of the most elegant and powerful safety concepts ever created.
So let's get right into it. Picture yourself up there, cruising miles above the clouds. What is the one thing that separates a perfectly smooth flight from a really bad day? A lot of the time, it comes down to this one simple, brilliant idea that protects against one of engineering's absolute biggest nightmares.
And that nightmare has a name: the single point of failure. And yeah, it is just as terrifying as it sounds. We're talking about one single component, maybe one wire, or even one screw, that if it breaks, the entire system comes crashing down. And in aviation, it's not an option.
So this is the core problem, right? Engineers have to design these incredibly complex systems where no single failure can ever be catastrophic. But how on earth do you solve a problem that big?
Well, you do it with a backup. But even better than that, you build the backup plan right into the heart of the system from the very beginning. You make the system stronger than the sum of its parts. And this is where things get really clever.
The solution is called a parallel system. You'll also hear it called a redundant system. The idea is actually pretty simple but incredibly powerful. You just have multiple identical components all doing the exact same critical job at the exact same time. It's kind of like teamwork, but for machines.
Okay, so let's dig into the logic here and see how this actually works in practice. This simple concept has a massive impact on safety, and it's all based on two really straightforward rules.
And this is the core idea right here. It's just so brilliant. For the system to be a success, only one of its parts has to keep doing its job. That's it. So for the whole thing to fail, every single component has to fail. And the odds of that happening? Well, as we're about to see, they are astronomically small.
All right, so just how much safer does this make things? Let's throw some real numbers at this, because we're not just talking hypotheticals here. The math actually proves just how unbelievably powerful this concept is. So for our example, we're going to look at a really key part of an aircraft's flight controls. It's called an Actuator Control Unit, or an ACU for short. Basically, this little device helps move things like the flaps on the wings. It's absolutely critical. And in our example, the plane has two of them working in parallel. Now, a single ACU on its own is already super reliable. It's got a 99% chance of working perfectly through a flight. And that sounds amazing, right? But here's the thing. In aviation, 99% is nowhere near good enough. We have to worry about that other 1%. That 1% chance of failure, that's our single point of failure. It might seem tiny, but when you think about the thousands and thousands of flights every single day, a 1% failure rate would be catastrophic. If we only had one ACU, that's our risk. So the entire goal of a parallel system is to attack that number and crush it. So how do we do it? Well, remember the rule. The whole system only fails if all of the components fail. And because these two units are independent, we can figure out the probability of total system failure by just multiplying their individual failure rates together. So that's 1% times 1%. And would you look at that result? The chance of a total system failure just plummeted from 1% all the way down to 0.01%. That right there, that is the power of redundancy. We added just one backup, and we made the system profoundly safer. So let's just take a second to put this incredible improvement into perspective. This isn't just some tiny tweak. This is a gigantic leap forward in reliability.
This table just lays it out perfectly. Look, we went from a 99% reliable part to a 99.99% reliable system. But the real story is in that failure rate column. We took a 1% chance of something going wrong, and we slashed it down to 0.01%.
And this chart just makes it so obvious. I mean, look at the size of that first bar. That's the failure rate for a single unit. Now look at that tiny little sliver next to it. That's the failure rate for our new system. It's not just twice as safe, it is 100 times safer. So what this really shows us is that redundancy isn't just an improvement, it fundamentally changes the game. It completely transforms reliability. This is one of the biggest reasons why flying is, statistically, the safest way you can possibly travel. It's all about hunting down and eliminating those single points of failure.
And you know, this whole idea, it doesn't just live inside an airplane. Once you know what to look for, you'll start seeing it absolutely everywhere.
Seriously, think about it. From the multiple brake systems in your car, to the backup power generators at a hospital, even to how data is stored across the internet, this principle of having parallel systems is a cornerstone of the safe, modern world we all live in.
So I'll leave you with this final thought. This powerful, life-saving concept is constantly at work all around us, but most of the time it's completely invisible. So the next time you flick a light switch or start your car, maybe take a second and think, where are the hidden backups keeping me safe right now? And what happens on that incredibly rare day when even the backup needs a backup?